Okay, today we're looking at Module 4, Lesson 5 on exponents. How many of you are familiar with exponents from elementary school? Okay, the other class is about 50-50 also. We've been talking about how repeated addition is related to what operation? Right. Repeated addition is related to multiplication, and repeated subtraction is related to division. Right. So today we're going to take that repeated addition, which is multiplication, and kind of take into a different direction. So right now I want you to evaluate these three problems in the opening exercise. Remember, evaluate means to solve. Oh, it's here over. Or this thing. Go there. Mine does. So go ahead and evaluate those three problems. 4 plus 4 plus 4 plus... Adding them all up. 4 plus 4 plus 4 plus 4 plus 4. 9 plus 9 plus 9 plus 9 plus 9. 10 plus 10 plus 10 plus 10 plus 10. And what is the first one? 44, agree or disagree? Disagree. What else did you get?
I first did 10 times 4 and then I got the answer 40.
Is the answer 40? Agree or disagree?
Agree.
Okay, so 40. When there's that many numbers, it's so much easier to make a mistake, isn't it?
Yeah.
What about the second one? Just give me the sum.
45.
And for the third one, the sum is 50. So how many of you solved these by counting up 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14? Okay, that's definitely a strategy that would work. How many of you counted by 4s? 4, 8, 12, 16? Okay, totally would work. But a lot of you didn't raise your hands, which means you didn't use addition. What other method did you use to solve this? So you multiply. So you use multiplication to solve this.
What I did was I counted how many 4s are, and I did 10 times 4.
All right, so you counted how many 4s there were. So this was the same thing. There were how many 4s? Whoops. Okay, so there were 10 groups of 4. Here we had 5 groups of 9 and 5 groups of 10. Right? Didn't that give us the same answers? Yes. So repeated addition, this is repeated addition. It's the same thing as multiplication. So multiplication is a faster way to add numbers when the adds are all the same. And that's the trick. They'll have to be the same. So when we add 5 groups of 10, we use an abbreviation and a different notation, which is multiplication. And that's just what we discussed on the last slide. So that was totally faster and easier, and we made less mistakes because it's difficult when you're adding so many numbers together. So if repeated addition gave us multiplication, what about when we see this, which is repeated multiplication? 10 times 10 times 10 times 10 times 10. I still have 5 groups of 10, but it's different now. When we added 5 groups of 10, it was 5 times 10. So when I'm multiplying 5 copies of 10, you write it like this. Does anybody know how to read that? Close. That would be 10 to the 5th power. Okay? So let's take a look at what that means and how it's different from regular multiplication. If we had 2 times a, think back to when we had the socks. When you have your coefficient, which is your number, and your variable, which is your letter, when there's no symbol written in between, what operation does that mean? Multiplication. So that means 2 times a. That means 2 times a. So if a equals 3, it means 2 times 3. So here I have 2 groups of 3. So 2 times 3 is the same thing as 3 plus 3. That's repeated addition. But now with exponents, we have here a to the second power. That means something different. That is not a times 2. This is a times 2. This means a times a. It's repeated multiplication. And the little number on top tells us how many times to multiply it. So now if a is 3, that means 3 times 3. And 3 times 3 is 9. And that's how you would write it. 3 to the second power. Absolutely. And we'll get to that. Absolutely. Your variable could be your exponent. Your variable could be your base. But these are words we haven't talked about yet. So let's take a look, and I want you to write some of this vocabulary on the top of your note page. So to review some vocabulary words, here, in this term, 8 to the 6th power. Any number, we're going to work with just rational numbers. Any rational number could be your base, and any rational number can be your exponent. This, actually, the 6 has 2 names. It could either be the exponent or the power. Those are both terms. It's not the exponent power. You should be copying your notes down. So the base is that repeated factor, and the exponent is also called the power. And then we have 2 special exponents that get their own name because they're special. When 2 is your exponent, it could be read as 5 to the second power, or we could just read it as 5 squared. And when 3 is your exponent, it could be read as 5 to the third power, or it's cubed. Those are all possibilities that we'll be exploring next year down the road. But if you wanted to one day come up during lunch, we can explore what that would be. But right now we're just going to stay with positive numbers and rational numbers.
It was like 6 to the second power would still be squared.
Yes, no matter what the base is, if this was x, any base to the second power is squared. Any base to the third power is squared. Question, cubed, sorry. Any base to the third power is cubed. See, my brain was already on my next question, I'm sorry. Can the exponent be larger than the base? And by larger, I'm not talking about the font size. I'm talking about the value, the amount. So could I have 3 to the 5th power? Can I do that? Absolutely. Can I do this? Can I do that? Yes or no? No. That means something different. You cannot do that. And that's the number one mistake that people make when working with exponents. People just, I see 2 numbers, let me multiply them together. I have a base, I have an exponent, I'm going to multiply them. You know. No multiplying base by exponents. That represents something, and that's what you have to show. Shall we practice some? You have to say yes. We're going to no matter what. Okay? So again, to review the squared and the cubed, 5 squared is 5 times 5, so that's 25. 7 squared is 7 times 7, so that is, shout it out, I'm pointing to the answer. 8 squared is 8 times 8, which is 16. So this answer, somebody had asked the question earlier, is it always squared no matter what the base is? And yes, if 2 is your exponent, it's always squared. So 1 squared equals 1 times 1, which equals 1. Cubed is 1 to the third power. 1 times 1 times 1 is 1. 2 cubed. 2 times 2 is? 4. Times 2 is? 8. Suppose somebody told me the answer was 6. What happened? If somebody evaluated this and said it was 6, what did they do wrong? I'm going to cross that out before somebody thinks that's a real answer. What?
They added to multiply.
Well, they could have done repeated addition. Absolutely, I didn't even think of that. It could have been repeated addition, or they did,
They multiply the base by the exponent.
or they multiplied by the base by the exponent, which you cannot do. 3 cubed is 3 times 3 times 3. Remember, the exponent tells us how many times I need the base. So 3 times 3 is? Times 3 is? 27, okay? So now you can go ahead, and I don't want you to evaluate 1 through 5. I just want you to write an equivalent expression. Just write an equivalent expression for each of those expressions. They're not terms. I was going to say terms. They're not all terms. Bless you. So for number 1, what is my base? 5. And I have 1, 2, 3, 4, 5. So what's my exponent? I don't like that example. They should have used different numbers. All right, for number 2, what is my base?
2.
And what is my exponent? 1, 2. What's my exponent? For number 3, what's my equivalent expression? Number 3. Very good. Number 4.
10 times 10.
Yes, let's count to make sure. 1, 2, 3, 4, 5, 6. Okay, now number 5. Now let's do number 5. Right. Okay, any questions on any of these?
Do expressions have equal signs?
No, very good question. What do we call the ones with equal signs? Equations. So expressions have no equal sign, equations have equal signs.
Do you have to do the dots, or can you do it?
You should get in the habit of using the dots for multiplication, because if I put x's here, how do I know that I'm not multiplying two different variables together? G times x times g times x times g. So if g equaled 2 and x equals 3, that would be 2 times 3 times 2 times 3 times 2. So at this stage of the game, we really want to get away from the x, because we can be confusing it with a variable. Easier done than said. Okay, did you have a question? No? Okay. What's the difference between 3g? Okay, so what's the difference between 3g and g cubed? Go for it. Oh my gosh, I love those vocabulary words you just used. So how would I write that out in the equivalent expression? If it's repeated addition, awesome. Remember, this is back to what we did when we were sorting socks. We couldn't put the blue socks with the red socks, just like you can't combine a G with an F. Okay, so this would be like an imaginary 1 here. 1G plus 1G plus 1G. How many G's do I have? 3 G's. Not on my iPad, but on the board I do. Okay? But now, continue with this beautiful answer, Naomi. What is G cubed? Oh, awesome. Repeated multiplication. And I hope all pencils are writing this down, which is G times G times G. Okay, so do you see the difference? Whoops! No, I can't see the difference because it's covered with a big keyboard on the screen. I used all my good stuff this morning. I don't know. Thank you. Come on, empty. Okay, so any questions? Do you see the difference? Who's not sure of the difference? Thumbs up, thumbs down, thumbs in the middle. Where are we at with this? Thumbs up if you totally got it. Thumbs down if you have no idea. Thumbs in the middle if you're shaky on it. Okay, I appreciate your honesty, so now I can clarify. Can you explain to me what makes it a little shaky? Like what part is confusing about it, or not really? Not really? Can you explain what part's a little...
Seems like
Okay, I'm glad you said that. What do you want to ask? Good. What do you want to contribute?
I thought repeated addition was G times G times.
Well, okay, so I'm going to answer both of your questions at the same time, hopefully. And I'm so happy that the two of you asked great questions. Repeated addition means I'm adding, I'm adding, I'm adding. I'm repeating the same thing again, 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 again. Okay, that's repeating. So I repeated my addition. I kept adding the same thing. This, I'm multiplying the same thing. So if I added my G's together, just like I added my blue socks the other day and I added my red socks, how many G's do I have here? 3, because you added them up. 1 sock plus 2 socks plus 3 socks, or 1G plus 2G plus 3G. So that's 3G. I have 3 G's. I added them together and I have 3 G's. This one is G cubed, or G to the 3rd power. When it's written as an exponent, it's not addition. Now it's multiplication. Instead of repeating my adding, I'm repeating my multiplying. So it's G times G times G. These we're adding. A little clearer? Let's try some more and see if that helps, okay? And if you're still confused on the homework tonight, tomorrow I'm going to have extra help. Even though it's Friday, I'm going to have math extra help, okay? So if you're still a little fuzzy on tonight's homework, come up tomorrow for lunch. We're not going to evaluate. Right now I just want expressions for time's sake. So, wait a second, these are decimals. Can I do repeated multiplication with decimals? Yeah, unfortunately we can. We're going to multiply these numbers together. So 3.8 times, how many times am I going to times it? 3.8 times 3.8 times 3.8 times 3.8. So I have it once, twice, 3 times, 4 times, because my exponent is 4. What would be an equivalent expression for 2.1 times 2.1? Squared, or to the 2nd power. Everybody repeat after me. 2 and 1/10 to the 2nd power. Or 2 and 1/10 squared. Excuse me? Sure. Well said. Very good. Or, he said 0 and 75/100 to the 3rd power. Or what? What's another way you could write it? Say it. Cubed. Exactly. So we did it with whole numbers, then decimals. Ugh, now fractions? If the exponent was 0.7, no, here I have it, my exponent it's just to the 4th power, to the 5th power. This one and this one are the only ones that I'm aware of that have special names. Okay, so that's squared, that's cubed, everything else is to the 4th power, to the 5th power, to the 27th power, to the x power, to the -4 power, but we're not going to get into negatives. or irrational numbers. Somebody wanted to use pi as an exponent. And I said, let's not get irrational here. Let's keep calm and stay rational. See, only like 2 smiles. That was a funny joke. All right. Thank you. Yeah. Anyway, a base number can be a fraction, but this time we need to be a little more careful how we write it. Otherwise, it could change the meaning. Okay, just so we were getting the hang of this, okay? How many 1/2s do I have? So 1/2 is my base because that's the factor. How many of them do I have? I have 3 of them, so it would be 1/2 cubed. But if I just put my cubed here, that could cause some problems. Because I'm cubing the entire 1/2. What have we been using to keep integers together? Just identify them. Parentheses. So you have to put parentheses. This way the whole 1/2, which is how that's the contradiction, the whole 1/2, whole fraction, the whole half. Come on! Now little something. Fine. So my whole thing, Mrs. Whalen's got my back. So the entire fraction is being cubed. Because if I did this, 1/2 cubed, that's 1 times 1 times 1 over 2. So what's 1 times 1 times 1? And then 2. But here, what's 1/2 times 1/2? 1 times 1 times 1 is 1. 2 times 2 is
4.
Times 2 is, I have different different products here, don't I? So that's why your parentheses are very important. Who knew? How important parentheses were in math? Number 10, how would we write that as an equivalent expression?
2/3 times 2/3.
2/3 times 2/3. How would we solve that? 2 times 2 is? 3 times 3 is?
9.
3 times 3 is?
9.
Thank you! You made me a little nervous with that last answer. It was more than one person. I'm not even going to repeat it on the blog. All right, take a minute, fill out this chart, answer the 3 questions on the bottom of the page. I'm going to have you come up and put the answers on the board. I'm going to pause the recording while you work. Okay, so here are the answers for the chart on the page. Carefully checking your multiplication and the placement of your exponent and counting how many factors you have written out. Now for the bottom of the page, write 5 cubed in all 3 forms. So we have 5 cubed, that's in exponential form because it's written with an exponent. Written as a series of products, 5 times 5 times 5. And then standard form, 5 times 5 is 25, times 5 is 125. Write 14 and 7/10 squared. So we have 14 and 7/10. This whole thing is squared. So that would be 14 and 7/10 times 14 and 7/10. For time's sake, we're not going to write the product. Now, one student thought 2 to the 3rd power was equal to 6. What mistake do you think they made, and how can we fix it? What did they do now? What did they do wrong? They did 2 times 3, which equals 6. And we know that's not what that means. 2 to the 3rd means what? How would I write?
2 times 2 times 2 is 8.
Right, so that equals 8. Okay, very good. Or perhaps what this person did was not repeated multiplication. Perhaps they did repeated addition, which is the same thing as 2 times 3. You have to be careful. You could have written 14.7 squared. Absolutely. It did not specify whether it had to be a fraction or a decimal. So either way would be acceptable. Okay? So an exponential form is when a number is written with the exponent and it represents repeated multiplication as long as the factor is the same every time. Okay? You're fuzzy on tonight's homework. Make sure you come to extra help tomorrow and we can go over it.